Right. So yesterday we have seen some first order and second order circuits and their differential equations. And we have verified that the circuit order depends on the number of storage elements, and that storage elements are inductor and capacitor. So if a second order circuit has inductor and capacitor only, then the circuit we can consider it is the second order circuit. If a circuit has only inductor or capacitor, then that circuit considered as a
First
first
order.
order circuit. Up to this, everyone is clear, I hope. So yesterday I had asked you to give answer a question in slide number 10. Can you go to slide number 10? Here it is written IL equals to 1 over L minus infinity to t time integration of Vc of tau d tau. Have you found any clue of this terminology?
No, sir.
Can you reply? Have you found any clue of this terminology or term of this
This
equation?
term has come from slide number 8.
Slide number 8, what have you seen?
Yes, sir. We have seen there that IL, the current of inductor, is equal to 1 by L integration 0 to t, the limit, VL respect to time.
Yes.
From this equation, we have got this one.
Then how it becomes VC?
VC.
Yes. Because in that equation it is written VL, but here is VC.
Voltage across
In
capacitor.
this equation, in this slide, we have seen that VC is equal to VL is equal to VR. That's why.
Exactly. Thank you. Excellent. Excellent answer. Yes, this is the thing. That's why everyone should focus previous slide, current slide, and future slides to have the answer. Excellent. Thank you.
Thank you, sir.
Now, today we will another thing we'll discuss, that is about the second order differential equation with missing y terms. In missing y terms means if we compare the slide number 12 with slide number 11, we can see on slide 11 it is written 3 terms of the equation. So these terms are available. There is no missing term, right? But on the slide 12, it is saying that slide 12. Y term missing means the last term is missing. That means only differential terms are available. So in that case, how can we find the solution of differential equation? That procedure is going to be discussed today. So you have seen the comparison of y available and missing y terms in the second order differential equation. So it is obviously easy to solve also the same way like slide number 11, but we are going to see new procedure to find the solution, and which is very effective even beyond second order differential equation, you can use this procedure. There is no limitation. But in the slide number 11, what process has been taught, that is limited up to second order differential equation. But today's topic has no limitation of order numbers. So it will go beyond second order equation, second order differential equation. So that here you can see the same procedure, the d square y of t dt square plus p dy of t divided by dt equals to g of t. G of t another function, and here variable is y of t, and g of t another variable function. So here we consider that first derivation equals to m. Understand? So m prime, that means the double derivation is going to y double prime. That's how the second line is constructed. After that, here we can see the integrating factor. And that integrating factor you learn in maths 197. I hope everybody remember the integrating factor. So that from integrating factor, we can write down e to the power integration of p dt. The p term actually the coefficient of first derivative term. Remember, here is critical point. What is p? Always remember, p is the coefficient of first derivative term. Understand? So we have got the equation for integrating factor. After that, we will find the mu of t, another term which is necessary to find the solution, final solution. So we need to find out the mu of t, and mu of t is equals to integration of u of t g of t dt plus c divided by u of t. How this term come? Look at the equation. U of t, everybody understand, that is integrating factor. G of t is the right side function of the equation. If it is 0, then you have to write down 0 here instead of G term. If it is supply voltage, then you have to write down supply voltage. If it is any constant number, you can write down any constant number instead of G of t in the equation of mu of t. And plus c is the arbitrary constant. We consider it is as an indefined constant. Divided by u of t. So this is the mu of t equation which is necessary to find out the final solution. And the final solution y of t equals to integration of mu of t dt. So if we look at this, yes, please.
What is E, sir?
P.
E, sir, E. Integrating factor ut is equal to E summation of P dt. So solve the mu t is equal to, sir, summation of ut gt dt. Then where is E, sir?
Okay, where is E? E is the exponential. E to the power x. Remember?
Oh, sir.
E to the power x, e to the power 10. That means the exponential term, the long term.
Okay, sir. Thank you.
Understand?
Yes, sir.
Sir, P is the coefficient of, sir,
First derivative term. First derivative means first differentiation d by dt. With that, anything available, then we consider the coefficient of that term. I will give an example in next slide. But here we are presenting the equations of each term. After that, we will have an example. And we will follow these, we will use these equations in the example and find the final solution of that example. Okay. So everybody got your answer, right? Now, here in case of final solution y of t, since in the given equation y is the variable, so that in final solution we have written y of t, then y of t becomes mu of t dt. Understand? So there is no limitation of this procedure until there is a complexity. That means that could be the longer analyze the what is called mathematical analysis. That's all. So many times you need to do integration, differentiation, integration, differentiation. That's the thing. Otherwise, you can get the solution easily rather than last process. So we are on slide number 13. So on the slide number 13, there is an example y double prime equals to y double prime minus 5y prime equals to 0. So everybody look at this equation. So we can consider this one is y double prime means d square y divided by dt square, and y prime means dy by dt.
Yes, sir.
So that we can compare with the slide number 12. It says the p term, right? P is
Yes,
the
sir.
coefficient of dy by dt. So and then what will be the p? Because there is a plus sign.
Shujaul, turn off your microphone,
P, right?
please.
So here will be p equals to minus 5 and gt equals to 0. So we have got p value and gt value. So we can find out the integrating factor. U of t equals to e to the power integration of minus 5 dt. It was written p dt. So p equals to minus 5. So here minus 5 has been put into the equation. After integration, what we have? E to the power minus 5t. Integration of constant dt. What is that? Result is constant, right? Constant means some numbers. Understand? Some numbers. So integrating factor has been found as e to the power minus 5t. After that, we need to find out the mu of t, and that mu of t equation, it is 1 over u of t. That u of t was actually the below the integration of u of t dt g of t dt plus c. So we have broken that equation in this way. After that u of t, we got 1 over u of t, that means 1 over e to the power minus 5t is going to be e to the power 5t. Then integration of, since g of t is 0, so total term of inside the integration is 0. Then plus c over u of t, that means c divided by e to the power minus 5t. So since 0 in integration is 0, so this first term is 0. So finally we have got c e to the power 5t. So c e to the power 5t is the value of mu t. Then getting final solution, y of t equals to integration of mu of t dt equals to integration of c e to the power 5t dt. C is the arbitrary constant, as I mentioned earlier. That c is still will be with the e to the power 5t because it's constant. Then integration of e to the power 5t becomes e to the power 5t plus c2. How this c2 coming? C2 coming in terms of indefined integration. When we found any indefined integration indefinite integration, then we put some constant. So that constant is C2. Understand? So our final solution coming C1 e to the power 5t plus C2. This is the final solution. How do you feel? Is it difficult process to find the solution, or is it easiest way to find the solution compared to the previous method? How is your impression about this integrating factor method to find the solution of differential equation? Easy, right?
Sir, in previous slide, sir,
Yes, sir.
mu t equation, sir, is the
Yes.
same as the right now's equation.
Yes,
Slide 13, mu t
I
equation.
am showing you here the slide number 12, that integration mu of t gt dt plus c divided by u of t. So if we can divide this term into 2 by plus sign, that means integration u of t g of t dt divided by u of t plus c divided by u of t, isn't it?
Yes, sir.
Yes, sir. This is the
Yes, sir.
magnitude of
Now I got it.
integrating factor.
Yes.
Sir.
So same
Yes.
equation here. Huh?
Same thing.
Yes, sir. This is the integrating
have any question?
magnitude.
Yes.
So one question, sir.
Yes.
So previous slide.
Slide
So
13.
here, yes, sir.
Yeah.
This slide. So solve mu of t. Here
Yes.
mu of t equal 1 divided u of t. Integration
Yes.
u of t g of t dt
Yes.
plus c divided ut equal, sir, 1 divided ut equal, we know that e to the power 5t. Integration, where is the value of ut, sir? Here only
Oh, right. So ut is e to the power minus 5t.
Yes,
That
sir.
is available, but since z value is 0, so the total term becomes
Yes, sir.
0.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Multiplication
I have
into
not
something
put,
equal to 0.
I have not put the each term, because we find that term totally is 0.
Multiplication. Yes, sir.
Yeah, multiplication is 0. So we did not put that. It's easy method, isn't it?
Yes,
Just
Yes,
you
sir.
need to know the integration properly.
Yes, sir.
Then you can find the solution easily. So same problem doing in another way. So no problem. Any question on this slide? Any lack of understanding? Because this method will be used from now on. If no problem.
Integration 0 is
Hmm.
Hello, sir.
Anyone has question?
Sir, when integration is 0, then it equal to t. Previous slide. The integration
I
0
could not catch you. What is your question?
the integration 0 dt equal to t.
Here,
Yes, sir.
0 dt. Okay, 0 dt. G of t. If we see g of t is 0, and u of t, whatever value has, the multiplication becomes 0.
And my question is integration 0 t equal to t.
No, integration 0 dt is the 0.
Oh,
Zero.
yes, sir.
0.
Okay, sir.
And finally, sir, integration c by e to the power minus 5t.
Yes. And I
That is
understand.
no integration in the
Yes,
under
sir.
C terminology.
Yes, sir.
Integration has been finished the earlier term.
Yes,
So
sir.
from c divided by e to the power minus 5t becomes
5t.
e to the power 5t c. Okay.
Sir, C1 equal to C by 5.
Sir, in this
C1
slide,
equals to C by 5. So e to the power x, okay, integration of e to the power x. What is the value?
5.
E to the power x divided by a, right?
X divided by A. Yes, sir. Yes, sir.
So that
Understand.
formula or concept has been used here.
Okay, sir. Thank you.
Clear?
Yes, sir.
Microphone is making echo.
Pardon?
Sir, someone's microphone is making echo. We are.
Can you stop your microphone? Can you mute your microphone? Please mute your microphone. Now another announcement for you. We are going to have the first term exam on the 4th week. Okay. So in 4th week, basically, will be from, since our semester has been start from 1st July, so that your 4th week going to be start from the 18, right? 18. Start from 18, so we can give so are you okay with the 19th July?
Yes, sir.
As we have discussed yesterday,
Yes, sir.
19th July.
19
So,
sir, already you give the exam date, sir.
yeah, I
19th.
already gave you 19th, right?
Yes, sir.
So is it okay
Yes,
for
sir.
you, or should we move little bit 2 or 3 days later? That means the next week.
No, sir.
No, sir, 19th is okay, sir.
19th is okay. Everybody agree?
Yes, sir. Yes, sir.
Yes, sir.
All right.
Yes, sir.
All right. Okay. Thank you. Now we are.
Sir, I have a
maybe-
question, sir.
Yes.
In first term, it says that,
Yes.
it says that in first term we have also faced our viva. Sir, so in 19th, we also give the viva exam also.
Yes. That's the very critical thing. The one, yes, 19th. If we arrange viva, can you give?
Sir, 48 students. It will take a lot of.
We don't have enough time for.
Sir, after exam, then you will take another day virus.
Sir, it takes a next
Okay,
class.
so 19th we will have written test. Okay,
Takes a
later we
next
will
class.
discuss.
So 19 we will have
virus thing.
later we
Okay, sir.
We will discuss, sir, later.
Okay. Our next slide shows the solution of first order linear equation. What will be the solution of first order linear equation? That's thing we need to know. And this, on this slide, I have shown you the generalized form of solution. As I mentioned on the first day, that a differential equation generally have two parts of solution. One is complementary function, another one is particular integral. So complementary function always available for homogeneous equation, and if the equation is non-homogeneous, then the complementary function plus particular integral will be the solution of that non-homogeneous equation. All right. So from this slide, we are presenting the general solution of a first order linear equation, differential equation. So the given equation, it says the P n minus 1 T of 1 T of dy by dt plus Pn of t y equals to g of t. How this equation come? Can you remember the nth order differential equation? Because the in nth order differentiation, the order was start from n, and it becomes up to the zero order. That means dy by dt 0. That means y term existed. Here, same thing. You can see. After that, we have taken the common of the coefficient of first derivation dy by dt. After taking out the coefficient of dy by dt, we have changed the coefficient of y term. That becomes a0. That means a0 going to be equal of Pn of t divided by Pn minus 1 of t. Understand? And as well as the g of t divided by Pn minus 1 of t equals to f of t. Everybody should focus on this reorganization, because in exam or in assignment, you may not have direct form of this equation dy by dt plus a of 0 t y equals to f of t. You may not have this one in exam, but you have to convert the equation in this form. If you don't convert in this form, then your solution will not be correct. Okay, so that
Sir,
everybody must reorganize. Yes.
sir, here A0 is equal to sir Pn into T y divided by P n minus 1 into T, right?
This is not into. This is the function of t.
Oh, function, sir, function of P.
Yes. Yes, exactly. Yes. So the solution is the summation of complementary function and particular integral. That means y equals to yc plus yp. Yc represents the complementary function and yp represents the particular integral. Then complementary function yc equals to c divided by u, where c is the arbitrary constant and u is the integrating factor, and that u equals to e to the power a0 of t dt. Earlier we have seen u equals to e to the power integration of p dt, right? The same thing has been used here, just change is a0, because in our equation here is a0 of t. So you have to replace this a0 of t instead of p. So you can find out the integrating factor. After getting integrating factor, then you have to find the complementary function y of c, and that y of c equals to c over u. Now the particular integral is yp equals to 1 over u integration of u multiplication with the f of t dt. That u already you have the integrating factor, and f of t available in the equation of right side of equation. So very interesting is that whatever you have practiced up to slide number 14, we are going to use on slide number 15, so that if you learn once the integrating method, so you can utilize in the solution of first order linear equation or even first order circuit like RL circuit, RC circuit, you can find out the solution by using this YC and YP method, integrating factor method. Okay, so everybody
Sir?
should, yes.
Can you repeat the second line, please, one more time?
Second line means the particular integral.
No, sir. From the starting point, sir.
Oh,
Second line.
the dy by dt plus a0 of ty
Yes, sir.
equals to f of t. The second line has been rearranged from the first line. First line it was written with coefficient dy by dt Pn minus 1 of t and Pn of t with the y. Because
Mute your microphone.
then the dy by dt becomes independent or free from coefficient. If we want to make any term free of coefficient, then we have to ignore or reduce that coefficient. How? That means we need to divide it with the same coefficient. So if we want to divide the same the equation by same coefficient, then same coefficient means the Pn minus 1 of t. So Pn minus 1 of t divided by Pn minus 1 of t dy by dt plus Pn of t y divided by Pn minus 1 of t dt equals to z of t divided by Pn minus 1 of t. So first term cancel Pn minus 1 of t divided by Pn minus cancel out. After that we have Pn of t divided by Pn minus 1 of t. So that equals to A0. And g of t divided by Pn minus 1 of t becomes f of t. This is the reorganization of this equation. Why we need to do this? Because we have seen the general form of first order linear equation is free coefficient terminals dy by dt. So we have to make that form anyhow. After that we have seen a coefficient with the y term. So we using the t considering a0. Understand? Because we need to find out the integrating factor.
Yes, sir.
So we have reorganized the second line. Any equation you have to make in this form. Otherwise, you cannot find a solution. Very difficult.
So that's here f of t means g of t by Pn minus 1.
Yes, exactly. Yes.
That's it. Thank you.
So today discussion up to this now is question and answer session. If you have question, ask me, I will answer. Otherwise, I will ask you, you will answer. Asif, can you close your video?